Okay, so today's lesson, in your journal, you include the theorem, but we need a definition first. So, please take a minute to define mid-segment. Write it down. It is the segment that joins the midpoints of a triangle.
We'll just put it on top of your spiral. Now get at your notes.
A mid-segment, segment that joins the midpoints of a triangle. So remember that this whole topic is all about the middles, the mids. We did midpoint yesterday on coordinate grid. We are doing mid-segment today. Tomorrow is going to be bisectors, cutting things through the middle. But mid-segment. Okay, along with the definition, we're going to draw a picture of a triangle, any triangle that you want to, and then find the midpoint of two of its sides. So I'm going to say this is my middle, and I'm going to say this is my middle. You can find all three if you want to, but I'm just going to go with two for now because the segment that connects those two midpoints is the mid-segment. Segment in the middle of your triangle.
That makes another triangle.
And it does make another. And if you connected all three mid-segments, which I'm not going to do because I don't want to confuse you, is here's another mid-segment, here's another mid-segment, and you can have your little, you could have a bunch of triangles.
Do female elephants have tusks? They do, right?
Wrong topic. I don't know. Here, if we took the midpoint of the hypotenuse and the midpoint of a leg, a mid-segment would be here in this triangle. Okay, so you can connect any two midpoints to make a mid-segment. Did y'all get the words in the picture to go along with it? Let me move that up a little so we can look at the theorem that you glued in. Okay, so this is what happens with a mid-segment. Really nice, basic, and hopefully very common sense. Okay, so first of all, it's saying that D and E are midpoints of those two sides, so we've connected, so the red is a mid-segment. Next, it says this is what happens. DE and AB are parallel. So the mid-segment, mark on your green picture, and the base that it is a mid-segment to are parallel to one another. Okay, so that means a couple of things. That means angle A, facing right here, and angle D are congruent. Y'all know why? What kind of angles are they? If the lines are parallel. Ah, that's it. Thanks, Holly. These are corresponding angles with my parallel lines, so they are congruent. So these are corresponding, and then these are corresponding, which makes those angles congruent. Not necessarily to each other, but these two are congruent, and then these two are congruent. Okay. The other thing that you'll notice is it says DE is half of AB. So whatever the length of AB is on your green paper, let's put 10 right there. This is my base, AB. As I go up to the midpoint of my triangle, I have now cut that base in half. So that distance from D to E is 5. Okay, common sense. Makes sense as you look at those theorems.
Is that with any kind of triangle?
Any kind of triangle. So I could have an obtuse, connect the midpoints. And no matter what this is half of it. I can have a right triangle. I could even connect the midpoint of this and the midpoint of this, and that's half. Or I could connect these midpoints. That is half of this. Okay. So depending on what the mid-segment is a mid-segment of, it's halfway up the triangle, and so it's half the distance. Okay. That even works, the steps in the sack that go down or go up, depending on which side. So here you're coming up toward like where the bathrooms are. You've got these are your steps down here. Even though it's not a triangle, you can kind of imagine it as being a triangle. And from the bottom step, halfway is going to be half the distance of whatever that is. And then you actually, so this is half the distance of the sum of these two. So anyway, that comes even later. But, okay, question about the theorem. and the parts that are created. So this is how we can use it. Let's do a couple of examples together. You don't have to draw this one, but we are going to discuss together. These are mid-segments. You can tell because this side was cut in half here at point T is a midpoint. This is cut in half, point R is a midpoint. This is cut in half, point S is a midpoint. So you've got 3 mid-segments. According to that, it wants us to list all the parallel segments. So if I pick the base DF, Skylar, which mid-segment is parallel to DF?
RS.
Okay, because those are parallel, you have your corresponding angles that are congruent as well. Okay, Kyle, name another set of parallel parts.
TSD.
TS parallel to, oh, not H.
TSHDB.
TS parallel to DE. Okay.
P, D, E. There's not even a P, Kyle. What are you talking about?
I know.
Okay, Tyson,
TMSD.
do you see the other set of parallels?
Well, he's SB 137.
We have RS and TS.
RS and DS.
So we have that one and that one, and we have this one and this one. Where's your other segment? And it would run parallel to? Yeah. Okay. As long as you know those are mid-segments, those parallel statements are true. Yes, sir.
How does it say B wall?
We're playing Wall Friday.
I knew that.
It's our opponent. I think they have Wall Hawks. So I didn't put the hawk up there this time. I just put Wall. All right, Holly. So, well, actually, I'll ask you in a minute. You guys go ahead and draw this picture in your journal. One sample problem to look at, and we're gonna fill out this information on the picture. But go ahead and draw a triangle DEF. Find the middles at R, S, and T, and then connect with the triangle. Okay, then once you have it drawn, RS is 2x units long. That's the segment, not an angle. DF is 6x minus 20. So label those, that's this full length here. And we're going to try to make an equation to solve for x. On these, you have 2 choices. You're in a
Shouldn't it-
relationship.
Since the midpoint is the same, shouldn't it just be like 2 times the length of RS equals DF?
That is one way, yes. Since this one is twice as big as this one, if you took the small one and doubled it, those would be the same length. Okay, so you can take 2 of the mid segments to equal its base, and you have your equation. Or, what could I do to make this one equal that? Cut it in half. In this case, that would work fine because both of those things can be half easily. So 3x minus 10 could equal 2x. Either equation is fine. If these are odd numbers and you don't want to mess with the decimals, then double the small one to equal the big one. Okay, so either set of equation can work. Let's go ahead and solve from here. If I move my 2x over, that gives me an x, and then when I move the 10 over, it gives me x's 10. Okay, so that's fine x. What's the length of RS, Holly?
20.
Yes, 10 times 2. So x is 10 and RS is 20. And we have our 2 answers. And the whole topic itself really is just as simple as that. I just wanted you to see the visual that if you have any kind of triangle, whatever the base is, and you go halfway at both sides, that distance is half of its base. Okay. One last thing. You don't have to draw or write this one, but I just want to show, like, in a real world situation, how could this be helpful?
Is that a shoe print?
No, it's a plot of land. Okay, so this is a body of water.
46 foot size shoe.
It does kind of look like a shoe print. But if you need to find the distance across a body of water, you can't obviously run a tape measure or a little measuring thing across the body of water. But if you could measure on dry land, you can make predictions based on these theorems. For instance, if I measured from here to here, and then took that distance out the same amount, so that this is my midpoint. Same thing on this side, so this is my midpoint, and I've created this triangle situation where I know this is 46 feet long from that. How do I find that?
You just
Double
multiply it times 2.
46. It's just doubled, so if you can, measure those out, then here's 46, then that, is gonna be 92 feet across the body of water. So it's just a way of measuring on dry land instead of having to go across the water, that you could use the triangulation to determine.
Lido, libido.
Okay, well, that's the end of the lesson today, so we have no homework assignment.
Breaking habit, drink Kool-Aid, cookie love.